All right, quadratic formula. The quadratic formula is just easier to use if you have it memorized. And besides that, it makes you look smart. You need to be able to say it and you need to be able to write it. It's one of those things that I'm expecting you to memorize. So take turns saying it. Look in the mirror and say it. Say it to your parents. Say it to your grandparents. Say it to your brother and sister. Say it to your dog. It is the opposite. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. If you don't say the all over part, we don't know what part is over 2a. If you don't say it, you're really indicating it's just over this. You have to have the x equals because it is a formula, so it's an equation. And the plus or minus b squared minus 4ac. This part right here is the radicand is called the discriminant, and we'll be talking about that later in the unit. So far there are two ways that we know how to solve quadratic equations. We can find the square root, and you can find the x-intercepts when you're graphing. When can't you use finding the square root? So when can't you isolate that x squared? 4x squared equals 100, divide by 4, x squared equals 25. Take the square root of both sides, x equals positive or negative 5. When can't you do this? Well, if there was an x term, if it was really something like x squared, so ax squared plus bx plus c equals 0, if we have this term, we can't isolate the x squared and have that as our only variable. So right now the only way we know how to do that is by graphing, finding that opposite of b over 2a. Think about where that is in the quadratic formula, by the way, and then making your t-table and graphing and then finding where it crosses the x-axis. So what we're going to learn today, the quadratic formula, is an easier way, less tedious way to solve a quadratic equation when you have the x term. So in a minute you're going to see that the first step in solving a quadratic is making sure it's in standard form. In other words, it has to be equal to 0. This one is equal to 0, but it is not in standard form because our x squared does not come first. And that's important because we want to make sure we have our a, b, and c correct. So it would be negative 10x squared plus 5x plus 25 equals 0. So it's equal to 0, and now the x squared is my leading term. Here they're out of order, plus it isn't equal to 0, so I'm going to subtract 2. So now I have 4 plus x minus 3x squared equals 0. Now that part is fixed, but it's still not in the correct order. So we have to put it in the correct order. And now we're good. So as I said, it's really important that you memorize a quadratic formula. It needs to look like this. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And again, think about what this part, how we've used this part before, the opposite of b over 2a. Remember what this is? It's the x-coordinate of the vertex, when we're graphing. And this is the discriminant, and we're going to be talking about what that tells us too. Remember, if you take the square root of a positive, how many solutions do you have? Of a negative, how many solutions do you have? Of 0, how many solutions do you have? So here's our first example. First you have to make sure it's in standard form. I have my x squared term, my x, and my number, and it's equal to 0. So check. It is in standard form. Next, you have to pull out the a, the b, and the c. It's just easier if you do this. So a is 1, because my x squared has a coefficient of 1. My b is 5, and my c is negative 14. And you know how I feel about substitution. you leave your parentheses and then go back and fill in the numbers. So the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now go back and get your numbers. B goes here and here. B is 5. So I'm going to write a 5 in there. A is down here and here. A and A is 1. So I'm going to fill that in with 1. And C is negative 14, and C is only in it once right back here. I'm going to have to write that like that. So because of the magic of TV, I already have this all multiplied out. X is going to equal negative 5 plus or minus the square root of 25 minus a negative 56, which is plus 56, all over 2. So X, I'm going to come down here, is going to be negative 5 plus or minus the square root of 81 over 2. So I like this one because the radicand is a perfect square, so that makes it easy. It is positive, so I know I'm going to have 2 answers. So at this point, just like we have done in the past, you are going to separate this into 2 separate equations. So negative 5 plus 9, because the square root of 81 is 9, over 2, and negative 5 minus 9 over 2. So negative 5 plus 9 is 4 over 2, which is 2, and negative 5 minus 9 is negative 14 over 2, which is negative 7. So our 2 answers, our 2 solutions for that quadratic is 2 and negative 7. Now I want to point out the importance one more time, and I've done this many times, of checking your work. Go back to the original equation and actually fill in, and I'll do it up here so you can see it, minus 14 equals 0. So our first answer was 2, so 4 plus 10 minus 14 does equal 0, so I know that that is the solution. And then if I do, and I'm sorry I'm writing all over the place, plus 5 times whatever x is minus 14 equals 0, and then I'm going to drop my other answer, negative 7. So 49 minus 35 minus 14 also equals 0. So we know that these 2 answers are both accurate. All right, one more example. I see here it is not in standard form. It needs to be in the correct order, equal to 0. So the first thing I'm going to do is add 4 to both sides. So now I have 3x squared minus 6x plus 4 equals 0. Now it's in standard form. So I'm going to pull out my a, my b, and my c. My a is 3, my b is negative 6, and my c is 4. Then I'm going to plug it into the quadratic equation. X equals the opposite of b plus or minus the square root of b squared minus 4ac. And again, see how I'm leaving those parentheses so I don't drop any negatives, all over 2a. And then I'm going to fill in my numbers. Remember that the b goes in 2 spots. It goes here and here, B and B. So I'm going to take that, I'm going to change colors this time. And then I'm going to pull my A. My A goes in 2 spots as well. And my C only goes in 1 spot. So the opposite of negative 6 is 6 plus or minus the square root. Negative 6 squared is 36, and that's why we needed the parentheses, because if you didn't, it would be a negative 36, and it's not. Minus 4 times 3 times 4 is 48, all over 6. So 6 plus or minus the square root of negative 12 over 6. And at this point, I'm hoping that you remember if your radicand is negative, it can't happen. We can't find a radical or square root of a negative number. So we know that this one is a no solution. Now one more point that I want to make. Let's say that this had been a positive. Let's say this had been plus. Then I would have had 6 plus or minus the square root of 84 over 6. And you will have many of those where it's not a perfect square and it's not a negative. I want you to get in the habit of not rounding until the very end. I would put it into my calculator like this. I would do 6 plus the square root of 84, enter. So enter, and then divide by 6. That way you're rounding at the very, very end, 2.53. So it's still an approximation, but it's a better approximation than if you had put that in and then rounded and then did the dividing. And then the second one would be 6 minus the square root of 84, enter. And you can use parentheses if you know how to do that. But do that part first and then divide by 6. You will have a more accurate estimation than if you rounded too soon. And that one would be a negative 0.53.